Yes, sir, it's working.
Yeah. So okay, so this is what we were talking about just now. So yeah, you can skip ahead. The S block, the P block, the transition elements are the D block, the F block, and the G block. So there, the G block is where we said that the if there are any new metals or there are any new elements, they would fit below the F block there. Right? All right, yeah, you can go on. All right. So these are some trends that I believe I gave. Yeah, we did this as a presentation, right? Some trends that occur within the periodic table. Now, the first that we look at is the atomic radius. And we see that as we go down a group, the atomic radius, uh, the atomic radius increases, or we say the size of the atom, then the size of the atom increases. And pick any row and look at it from top to bottom. Generally, you see that trend. As you go from top to bottom, there's a general increase in the size. And that's simply because remember we said each period represents a certain number of shells. So obviously, if we have more electrons and more shells being added, then uh, the atom is getting bigger and bigger because it has to accommodate all of these different energy levels. Next, please. Good. Now, why, go back, please. Yeah. Why does the, go back to the previous slide. Now, we see there that the radius also increases to the left, right? So meaning if we're going to the right, it decreases. So from sodium to argon, if we're looking at period 3 there, from sodium to argon, it's actually decreasing. So why is it decreasing in that direction? Simply because of this. The number of shells aren't increasing. So the electrons are basically the same area around the nucleus, but the size of the or the strength of the nucleus is getting bigger and bigger. So if there are no more energy levels for the electrons to occupy, there are no outer energy levels, they're occupying the same energy levels, but there are more protons in the nucleus now. The protons is becoming, the nucleus is becoming stronger and stronger. And so the pull of the nucleus is even greater and it shrinks the, the atom. For example, let me just look at sodium versus magnesium there. That's on the third row. The first two elements in the third row, sodium and magnesium. Sodium would have 11 protons in the nucleus. Remember, the protons are positively charged. They pull on the electrons. So if I'm going to use it in the middle here. If the protons, the nucleus in the middle has 11 protons and the electrons around them are being attracted to the nucleus, when we have 11 protons, the nucleus has that pulling power, that strength, right? But now if we have, say, 12 nuclei, if we have 12 protons inside the nucleus instead, that's stronger. That's a stronger pull. So now we have more protons pulling on the electrons. The entire nucleus becomes stronger. There are 12 pieces pulling now. That pulls in the electrons even more. So it shrinks. So that's why magnesium. Now, aluminum, who has 13 protons, is pulling even stronger. Silicon has 14, phosphorus has 15. So more and more protons are being added to the nucleus. And therefore the nucleus is getting stronger and stronger, squeezing in the electrons, and thus the atom gets smaller. So that's why as we go to the left, the radius or the diameter increases, and as you go to the right, it decreases. Yeah, next slide, please. So here we have a graph showing you the atomic radius changes. As we go to the left and right, we see sodium to argon, the radius dropping, 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 and the nuclear charge, ZEFF represents the effective nuclear charge. Now, you don't need to know about that so much right now, but just think of it as the pull of the nucleus. Next year, we'll be looking at this more in detail, but for now, just take it as the pull of the nucleus. So what we're seeing there from sodium to argon, the pull of the nucleus is getting stronger and stronger. And as that is happening, the atomic radius is getting weaker and weaker. Sorry, what am I saying? The atomic radius is getting smaller and smaller. Next slide. So because of that, when an atom loses an electron, the positive force exceeds the negative force, the negative charges. And so there's even, you can consider that an even greater pull. So sodium ion is actually smaller than the sodium atom. And the magnesium ion is smaller than the magnesium atom. Next slide. So when a nonmetal gains 2 electrons, the opposite happens. Now, because there are more electrons, it's harder for the protons to hold all of these together. So they kind of spread out a little bit. So anions or negative electrons, negative ions are larger than the atoms.
So what does ZEFF mean again?
For now, it's the effective nuclear charge. But for now, just think of it as the, this is actually how some of my students used to call it previously. Yeah, so it's actually the, think of it as the pull of the nucleus, the attraction by the nucleus. Next slide. Now, ionization energy is the energy required to remove electron from the atom, right? And generally, the ionization energy decreases as you go down a group. Why it decreases as you go down a group? Because the atom is bigger, the nucleus has a harder time to hold on to. So as you go down, the atom gets bigger. It becomes more difficult for the nucleus to hold on to the electron. And so it requires less energy to remove it. So ionization energy is that energy required. So if it's easy to be removed, it means it requires less energy. So ionization energy decreases down a group. And across a period, the opposite happens, where the atom is smaller, the nucleus and the protons it's holding onto the electrons even stronger, so it becomes harder to remove those electrons. So the ionization energy increases as you go across from left to right. Next slide. Electron affinity. It's the energy change that occurs when an electron is added to an isolated atom in the gaseous state. So just think of it as the, if you just want to remember the trend, think of it as the ability to want to be negative then, right? So it decreases down a group. Because it's so easy for it to lose an electron, it decreases down a group and increases across a period, because the more negative stuff are to the right and the less negative stuff or the positive stuff are to the left. Next slide. So this is just a summary of everything that we would have discussed there just now. Metallic character is tied in with the size as well, because if we're seeing that a metal, well, and I discussed this previously as well, but metals tend to want to lose their electron. So we're seeing that it's easier for the bigger atoms to lose their electron. So as you go down, the metallic character increases. As you go up, it decreases. Also, as you go towards the left, it increases as well, because the left elements are larger than the right elements. So you would see the most elements being all the way down and all the way to the left. And the most non-metallic are the ones tilt to the top and to the right. Next slide. Oh, that's it. All right. So, well, 1 hour. We did say 1 hour. So that would have been all. It's a good thing. Oh, we do have another one, but we'll look at that on Thursday. But I completely forgot that I skipped something, and I was supposed to come back to that before we started the periodic table. We were supposed to do that as soon as we finish the last slide, and as soon as we finish electronic configuration. It totally slipped me. So in the next class, we'll finish off periodic table and we'll go back to that stuff. The reason why I skipped it is because I wanted you to get an idea of electronic configuration before, and the structure of the atom before we go back, before we look at that. So we'll discuss both on the next day. We'll finish off periodic table and go to that, and we'll look at chemical equations. We'll try to work out some chemical equations. And at the end of Thursday, you should be ready for your first test. So without any delay, your first test would be on Tuesday. So I'm giving you 1 week's notice.
So like you mean
What exactly the test?
The test will focus on, oh yes, so what the test will be focused on, it would be everything up to balancing equations, which will be completing the coming day, Thursday, I believe.
Sir, are we having a final test?
It's
A final exam?
four individual tests. No final exam. But the last
Okay,
one
sir.
would be written during the time of finals.
So is it multiple choice?
Okay, so you would have some multiple choice, some essay types. I'm sorry, some multiple choice and true and false. I'm not entirely sure as yet if you would have specifically essay types, but
First thing is the first test, can it be multiple choice and true or false?
we'll see. Most likely yes, but I won't be able to guarantee.
Okay.
Yes.
Sir,
Anyone else?
It's on Thursday. Yeah. It's on Tuesday. The test is on Tuesday.
Tuesday, right. So please tell your other lecturers that you have a test on that day. And hopefully they're lenient with you as
I didn't hear that.
No, I said you can tell your other lecturers that you have a chem test, so they can give you free time to study, like how I just give you free time to study.
Yes, yes, sir.
Sir, only you to do that.
I know.
So
that's why I tell you to ask. Try your luck.
So is it coming on all the slides that you post on Moodle?
No, don't study all, because I sent extra. So study up to, well, I believe that would be lecture 9 or 8.
Up to like 10.
Anyway, whatever we complete on the next day, that would be everything. So don't study
Okay.
everything on the that I posted, because I posted some extra stuff that we aren't looking, we won't be looking at as yet. You can stop recording now.